Today, in this lecture, I will be taking up a very good practice problem in algebra which involves sequence and series. An excellent problem. It's not a regular problem. It's a problem not only depending upon n value in the sequence, the value of a is also variable, and under various conditions what will be the behavior of this sequence and series. When it gives a fixed value, when it tends to the infinity value. That's what we are going to find out, and by solving this problem. It's a very good problem. Please pay attention to it. Lot of concepts will be cleared while solving this problem, and many series and sequence, general standard series will also be, we will be coming across, and they will be dealt with while solving this problem. Kindly pay attention till the end of the solution. We will proceed further for solving the problem. What is the problem? 1 by eighth root of n to the power of a plus 1 plus 1 by eighth root of n to the power of a plus 2 plus up to 1 by eighth root of n to the power of a plus n. Here n is varying and also a is varying, the power and root also. Under these circumstances, for various values of a, how this particular series is going to behave? When a is equal to 0, what happens? When a is equal to 1, what happens? When a is equal to greater than 1, what happens? And a is in between 0 to 1, what happens? These are the various conditions we will be dealing with, and we will be understanding. Now, let us solve the problem. What is the question given here? Question is, find sum of the series one by eighth root of n to the power of a plus 1 plus 1 by eighth root of n to the power of a plus 2 plus up to 1 by eighth root of n to the power of a plus n is equal to how much? Now let us try to solve. The initial value, we will take it as solution. Please follow step by step. When a is equal to 1, what happens? The series becomes 1 by n to the power of 1 plus 1 to the power of 1 by 1 plus 1 by n to the power of 1 plus 2 to the power of 1 by 1 plus 1 by n to the power of 1 plus 3 to the power of 1 by 1 plus up to 1 by, how you can write eighth root of x is equal to x to the power of 1 by a. That is from basics of exponents. That's what we have applied here. Then a is equal to 1, it is taken as eighth power means 1 by a. A is equal to 1 means 1 by 1. N to the power of 1 plus n to the power of 1 by 1 is equal to how much? When a is equal to 1. The series becomes like this. Now, that will be 1 by n plus 1 plus 1 by n plus 2 plus the series becomes this value. N plus 3 up to 1 by n plus n. That is 2n is equal to how much? That means the series value will be when a is equal to 1. This is a standard series. Whose value will be, it is nothing but, if you say n plus 1, n plus 2, n plus 3 up to n 1 by n plus n. This can be written as can we write this sum as Sn is equal to can we write it as n by n plus 1 into n plus n by n into n plus 2? Can we write like this? Yes, we can write. Let's expand. N by n into n plus n. This is equal to how much? That implies Sn is equal to this can be written as 1 by 1 plus 1 by n. Can we write like this? Into 1 by n plus 1 by n into 1 by 1 plus 2 by n. Can we write like this? Plus up to 1 by n into 1 by 1 plus n by n. Can we write like this? That will be 1 by n, you take it common, 1 by 1 plus 1 by n plus 1 by 1 plus 2 by n plus 1 by 1 plus 3 by n plus up to 1 by 1 plus n by n. Can we write like this? 1 by n into sum of n is equal to 1 to k. Sorry, k is equal to, here we let us take some k value instead of n. k is equal to 1 to n. Let this value be k. Let this value be k. Sum of the series k varying from k to n. And what will be the series value? The series will be 1 by 1 plus k by n. We can write like this. Let us say x is equal to k by n. Then it becomes integral 0 to 1. 1 plus k by n is 1 by x. Summation is nothing but integration. 1 by 1 plus x. This value will be this value. This total value. Then it will be dx. When x is equal to n, k is equal to 1. When n tends to infinity, x tends to 0. When k tends to n, here what happens? When k tends to n, x tends to 1. When k is equal to k is equal to n means x is equal to 1. When n tends to infinity, x tends to 0. Hence, this can be written as like this. Now, what is the value of 0 to 1, 1 by 1 plus x dx? That is equal to ln 1 plus x 0 to 1, that is equal to ln 2. That means the sum Sn is equal to ln 2 when a is equal to 1. This is one answer. It converges. It's a standard series. You please check it anywhere. From any textbook also you will get it. This value is a standard sum. This value is ln 2 when a is equal to 1. It's a standard series. And to get this ln 2 value, this is how we have to proceed, and we have to convert it into a series of 1 plus x, where x is equal to k by n. And this is equal to ln 2. Now, what happens when a is greater than 1? Next question comes when it is very important, a is greater than 1. When A is greater than 1 series, what happens? What is the series? 1 by n, k is equal to 1 to n, sum of the series sigma 1 by 1 plus k by n, 1 divided by 1 plus k by n. This is for A is equal to 1. If A is greater than 1, it implies sum is equal to 1 by n to the power of A plus 1 to the power of 1 by A plus 1 by n to the power of A plus 2 to the power of 1 by A plus so and so up to 1 by n to the power of A plus n to the power of 1 by A. This will be the series. This will be equal to a general series item. This can be written as sigma k is equal to 1 to n. Let us say this is the k value. This is k. K is equal to 1 to n. What happens? How to write it? K is equal to 1 to n. Sigma 1 by n to the power of A plus k to the power of 1 by A. Because 1 to the power of 1 by A is 1 only, when A is greater than 1. This is the general series. General series. In general form, it can be written like this. When A is greater than 1 or for anything, this is general series. When A is greater than 1, what happens? K varies from 1 to n. Can we write this in other way also? This can be written as 1 by n sigma k is equal to 1 to n. This particular value, let us remove the division. Let us write like this. 1 plus k by n to the power of A to the power of minus 1 by A. Please cross check whether it is correct or not. This is how we can write. Similarly, what I have written previously from this. How we have written here? Like this. From here, I got this answer. I got this expression. Similarly, from here, I got this expression. Now, k varies from 1 to n. Now, here, when A is equal to 1, the crucial value is k by n. When A is greater than 1 or is not equal to 1, the crucial value is k by n to the power of A. What is its behavior? That is more important. As a is greater than 1, it implies one by n to the power of a is less than or equal to k by n to the power of a, depending upon the value of k. If k is equal to 1, it will be equal to, if k is equal to 2, this particular 1 by n to the power of a is less than 2 by n to the power of a, like that. This will be less than or equal to n by n to the power of a. What is n by n to the power of a? 1 by n to the power of a minus 1. Then let us add 1 to it. 1 plus 1 by n to the power of a is less than or equal to 1 plus k by n to the power of a is less than or equal to 1 plus n by n to the power of a. That means 1 plus 1 by n to the power of a minus 1. Now, when we use the negative exponential in this, the inequality reverses, like, because minus 1 by a, if you use it as an exponential, then 1 plus 1 by n to the power of a minus 1 whole to the power of minus 1 by a is less than or equal to 1 plus k by n to the power of a to the power of minus 1 by a is less than or equal to 1 plus 1 by n to the power of a to the power of minus 1 by a. But what is the value of 1 plus k by n to the power of a? This is Sn by n. Let us divide everything, let us multiply everything by 1 by n. What happens? 1 by n into 1 plus 1 by n to the power of a minus 1 to the power of minus 1 by a is less than or equal to 1 by n into 1 plus k by n to the power of a to the power of minus 1 by a is less than or equal to 1 by n into 1 plus 1 by n to the power of a to the power of minus 1 by a. What happens? What is this value? This value is nothing but sum, Sn. That means 1 by n into 1 plus 1 by n to the power of a minus 1 to the power of minus 1 by a is less than or equal to your sum. It is less than or equal to 1 by n into 1 plus 1 by n to the power of a to the power of minus 1 by a. Now, a is greater than 1. When a is greater than 1, a can be infinity also. A can be anything. What happens to this value? When a becomes infinity, a is greater than 1. That means it can be infinity also. This whole value will be 0. This will be 0 as a tends to infinity. And something to the power of 1 by infinity is 0. That means something to the power of 0 is 0. Something to the power of 0 is 1. For example, if n tends to infinity, also this becomes 0 and this becomes 0. This implies 1 plus 1 by n to the power of a minus 1 to the power of minus 1 by a is less than or equal to Sn is less than or equal to 1 plus 1 by n to the power of a minus 1 by a. This implies as per squeeze theorem, as this tends to 0 and this tends to 0, then the value will be Sn is equal to Sn converges to 1. That means case 1, when a is equal to 1, Sn tends to ln2. Case 2, when a is greater than 1, Sn tends to 1. Then case 3, what happens? Let us see. 0 is less than a is less than 1. What happens to it? Here, in the third case, where 0 is less than a is less than 1, what is the value of Sn? The original Sn? Sn is equal to sigma k is equal to 1 to n 1 by n to the power of a plus k whole to the power of 1 by a. This is the value of the sum of the series given. Here, what is here given? A is less than 1 and a is greater than 0. The value of any nth term in the series is 1 by n to the power of a plus k to the power of 1 by a. That is equal to, we have already seen that value will be 1 by n into n by n to the power of a plus k to the power of 1 by a. This is written as nth term is equal to n to the 1 by n into 1 plus k by n to the power of a to the power of minus 1 by a. This is what we have got from the previous discussion. Now, if n tends to infinity, what happens? K by n to the power of a when a is greater than 0 and less than 1 will be 0. This will become approximately equal to n to the power of a approximately equal to, this can be neglected, this one value you kindly neglect. Let us say we are taking the approximate value. This will be 1 by n into k to the power of minus 1 by a divided by n to the power of a into minus 1 by a. This will be equal to k to the power of minus 1 by a. This is the nth term. Then what will be the sum? Sn is approximately equal to sigma for large values of n. For k is equal to 1 to n, 1 by k to the power of 1 by a. As 0 is less than a is less than 1, that means one is less than 1 by a is less than 0. No, 1 by a is not less than 0, because a is positive means 1 by a will be positive. A is greater than 0. A is greater than 0 means 1 by a is greater than 0. And also 0 is less than 1 by a. That means 1 by a is greater than 1. And as k tends to infinity, 1 by a greater than 1, Sn is approximately equal to sigma k is equal to 1 to n, and n is very large, k to the power of 1 by a. K to the power of 1 by a means one by a is greater than 1, k tends to infinity. As it tends to infinity, the sum end value will be becoming 0 slowly. This converges. Sn converges when 0 is less than a and less than 1. Now, the other case we have to consider, case 4, when a is equal to 0, what happens? Sn is equal to sigma k is equal to 1 to n 1 by n to the power of a plus 1 to the power of 1 by a. That will be sigma k is equal to 1 to n 1 by n to the power of a. N to the power of 0 is 1, 1 plus 1 to the power of 1 by a. This is not 1 plus 1, this is n to the power of a is 1. But if n tends to infinity, infinity to the power of 0 is undefined. N to the power of 0, but for infinity to the power of 0 is undefined. That means this value will be k is sigma k is equal to 1 to n 1 by this is n to the power of a plus k. It is not 1, it is k. One plus k. If we say that before just infinity, if I take a value, then this will be something to the power 0, that will be 1 plus k to the power of 1 by 0. That is equal to sigma k is equal to 1 to n to n 1 by 1 plus k to the power of infinity. K is always from 1 to infinity. That means 1 by something greater than 1 to the power of infinity will be 0. Hence, that implies Sn is equal to 0. The final answer is in all the case 4, one is case 1, a is equal to 1, it implies Sn is equal to we have written just now a is equal to 1, Sn is equal to ln2. When a is equal to 0, Sn is equal to 0. When a is equal to greater than 1, Sn is equal to 1. When 0 is less than a is less than 1, Sn is equal to some convergence value it converges to some zeta function in 1 by a. Some function in 1 by a. That function we have already defined here. It converges. That means it never diverges anywhere. For the given values of a. This is the answer. It's a very lengthy question, but however, I took it as a practice question because there are many concepts made clear in this. To find the convergence and divergence of a series, and also a series with variables n and a, and we have found when series depending on series value depending on value of a, where a is equal to 0, a is equal to 1, a is greater than 1 and 0 is less than a is less than 1. These conditions are tested, and for conditions we found the finite value. For some conditions we can't get the finite value, but we have got the zeta function. And zeta function, and for this value also, last value, the sum converges to a certain value. And in addition to that, what we have learnt is that we can approximate the series under certain conditions. Approximation of series value, that also worked here, and we have done it. And we have seen that some function at L a is equal to 1, that means 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by 2n. Not 1 by 2n, 1 by a is equal to 1 means n to the power of a, that is 1 by 2 plus 1 by 3, 1 by 2n, it tends to ln2, a fixed value. And we have seen for different values of a is equal to 0 and a is equal to 1, how to find out the sum of the series. It's a harmonic series. Harmonic series also we have got a concept on it, and it's an excellent example for practice. Best of luck to everybody. Thank you for listening to me, and if you feel there is a value addition to your knowledge, kindly share and subscribe to my channel Maths and Science by IITIAN. If you have any doubt in the problem, I went slowly because I wanted to clear the concept step by step. If you have any doubts, please comment in the comments column. I will answer them. But it's a good problem. Practice it.